there are some cool things that you can do when you find the fundamental matrices that relate different views to each other, okay? Because essentially you can figure out which points correspond to which other points. One, which is really kind of interesting, is suppose I've got a pair of views of a scene, and what I'd like to do is do some stereo. And I know that if I solve for the fundamental matrix, I could, for every point, I could find the epipolar that's along and search along that. But of course, every point lands on a different epipolar line. What you can do is what's called image rectification or stereo rectification, where you take your original image, and if you find the fundamental matrix, you can essentially unwarp, maybe that's not the right word, just rectify is the right word. So it's as if the two images were taken with parallel image planes that are aligned. And why is that good? Because it makes me happy. No, it's good because you can get public. No, it's good because then it means your stereo solution now is just moving along the horizontal line. So your search is not just 1D, because it was 1D before, but it's a particular known one-dimensional search. Namely, every point here corresponds somewhere along the corresponding scan line in the other image. And that was done nicely. Comes from this paper here shown in 1999, showing you a real example that they did that comes from their paper. Here you see two images taken from radically different views of this very weird sculpture. The lines that are drawn on there are the epipolar lines, and you'll notice they're skewed and they go off this way. All right. After you do the stereo rectification by finding the fundamental matrix, you get horizontal epipolar lines, which was the whole point and allows you to do the stereo algorithm.